7.6 on page 401 is the cross product of two vectors. Okay, the cross product. The cross product is another way to multiply vectors, but it's a little different from the dot product. Cross product is also called the vector product, and as you might think, it generates, when you take a cross product to two vectors, it generates another vector. So by definition, the cross product of two vectors generates this other vector that happens to be perpendicular to the first two vectors. Okay, so this is defining three space and planes. Okay, so think about the xy plane. Okay, maybe shown over in the picture here with your thumb and your right hand. Okay, so use your right hand and try and get that three plane system developed here with pointing your thumb up, your index finger pointing out, almost like a toy gun, and then your second finger pointing sort of towards you or in a different perpendicular direction. Now notice that, I mean, it's a rough way to do this. This is legit though. This is called the right hand system for looking at a plane, and you can look it up on the internet. It's fine. But you basically use your right hand and look at the xy plane here. Now, any one vector is perpendicular to the other two vectors, okay? And that's really the definition of the three space. Okay, so the x-plane is perpendicular to the yz plane, or sorry, the x-axis is perpendicular to the yz plane. Okay, and the yz plane is defined by the y-axis and the z-axis. So that's the cross product, and that's how you generate that third perpendicular vector. If you're given two vectors and you take the cross product, what you've found is a perpendicular vector to the original two. There's all kinds of other applications and rules and just ways that you can think of this. Okay, there's a corkscrew rule on the internet. You may see this in first year. Some of these old professors really take a look at some of the traditional ways to define this type of stuff here. So the corkscrew rule basically, okay, is, if you know what a corkscrew is, and notice that, I mean, you can apply, okay, this pressure and this torque. So going one way, x as it crosses over to y, let's say, generates or pushes the z axis, or the z vector out from the xy plane. Okay, so that's really how a corkscrew works. So look at this particular example, okay, as saying, okay, x cross y. Okay, so as x goes to y, it's generating this perpendicular vector z here. Okay, so if you rotate x, another way to say that is if you rotate x towards the y-axis using the shortest possible path, this corkscrew goes in a positive direction on the x-axis. Okay, a couple of things about cross products and vectors. Okay, given a vector A and a vector B, the cross product, or the vector product, it's also called, right? This vector product, okay, A cross B gives or generates, you'll hear, it generates a vector that's perpendicular to both A and B. Okay, I'm going to make those vector quantities. Okay, so both A and B. So that's really what this is. Okay, so if I draw that, okay, this will be A cross B, okay, and this is vector A, and this is vector B. Okay, so as you might begin to think and wonder, this is found using a pretty complicated formula, if you like. If I have two vectors, A and B, given in components, I have to find another vector when I take the cross product, and it generates quite a formula. Okay, so it generates, this is my x component, this is my y component, and this is my z component. So it looks like the x component is generated by ay, okay, times bz, subtract az times by. Okay, so the x component doesn't, okay, so the x component of my cross product doesn't use the x components at all in the individual vector products. Okay, it uses AY and BZ and AZ and BY, and similarly, okay, to find Y, to find the Y component, I use Z and X. And similarly, to find the Z component, okay, I use X and Y. Now, it helps to remember the reason for this, maybe this way, because as we said in our definition, we're generating a vector product. So if I'm talking about X and Y vectors, it's generating the X axis, right? It's generating a perpendicular vector. So in a lot of cases, that's the way this looks here. Now, this is confusing for students to remember, memorize this formula here. A nice, easy way to do it, though, is look for a pattern here. Okay, so here is the pattern that we try and do, and I'm going to explain it to you here. So if I have a vector A, I'm going to write my vector A like this. I'm going to write my second component, and I'm going to write it in a column. I'm going to write my Z component, I'm going to write my X component, and I'm going to circle back to my Y component. Okay, I'm going to write this in a column. And beside that, I'm going to do the same with my B vector. Okay, so I'm going to start with the second component, the Y component for B, and then I'm going to write my B Z component, and then I'm going to write my B vector, my X component, and then I'm going to write my circle right back to my beginning, so my B, my Y component. Okay, so I write it in columns, right? I write it in columns here, like this, all the way down. Okay, so now my vector cross product, okay, is going to be found with, I just need to get a different color pen, okay, is found by taking, okay, with the cross product. So I make an X, okay, and I multiply AY times BZ, okay, that was the first one, take away AZ times BY, okay, and that's this thing right up here. Okay, my next component, my Y component, is found by making another X across, right? So that would be AZ times BX subtract AX times BZ. So that was this one here, AZ times BY, take away AX times BZ. Okay, and then finally, I just have to finish off this cross product. So I've got AX times BY subtract AY times BX. And notice that's this one here. Okay, so the Y component, one we didn't focus on, is this expression right here. Okay, that's how you do it, and it's going to take a little bit of practice. There's some homework questions, and there's a couple of examples here that we'll work through here. But once you get the hang of it, you follow the pattern and you do it this way. Find it easy, pretty easy way to do it. This is how the textbook does it. I've seen it done in rows. If you'd like to go on the internet and try that and see if you can find a different way to do it. Or I've seen students just memorize the formula. I'm not big on memorizing formulas, but I like to learn things through patterns, and this pattern seems to work well. Okay, let's take a look at the first example here. Okay, so the first example is I've got to find the cross product of these two vectors. So I've got to find the cross product given my two vectors. Okay, so I'm going to set up my little T-chart. I'll do it over here. So I'm going to start with my first vector. I'm going to write -2, 0, 1, and -2. So I start at the Y component. I go Y component, Z component, X component, Y component, circle back to where I started. And then I'm going to line that column up with -1, 2, 0, and -1. And then I'm going to generate, okay, this times that. Okay, so -2 times 2, I'll just do it over here, -2 times 2, take away 0 times -1. Okay, so -2 times 2 is -4, right? Take away 0. So I've got a -4 here, and that's going to be my first component. Okay, the next one. So 0. Sorry, I had a grumpy dog here barking to get outside here. So the next component, the y component of my cross product, is 0 times 0. And that was these. Okay, subtract 1 times 2. And 0 times 0 is 0, so take away 2 is negative 2. That goes over here. And then my last component is 1 times negative 1. Okay, take away negative 2 times 0. And that'll be negative 1. And that is my cross product. Now I can verify the cross product, okay, and you're asked to do this in the homework questions. I'll do it for the one, okay? You can verify this cross product by finding the dot product of one of the vectors and the cross product, okay? So to verify, okay, you can take one of my vectors, sorry, it's either one, you can verify both of them, in fact, okay? So I can take one of my vectors and dot it with, okay, and the fact that I know that the cross product is perpendicular to the given two vectors, the dot product should be 0, okay? So this dot product would be, okay, negative 4, okay, that was 1 times negative 4, plus negative 2 times negative 2, plus 0 times negative 1. Okay, it looks like I've got negative 4 plus 4 plus 0, and that equals 0. That should, okay, verification. Now I could have also did this vector here to verify it as well too. So take the second vector and dot it with the calculated cross product here, and you're always going to get 0. That's the definition of, okay, of finding a cross product. Okay, let's do another one here. Practice, practice, practice. A happens to be, I'm going to write it as, okay, components, negative 1, so it's ijk, and B, okay, would be the vector 1, negative 2, and negative 1. So my cross product, okay, is going to be negative 1, 2, 0, plus 1, negative 2, 1. The only issue with cross product is it's confusing sometimes. If you're not on your game here and you don't know exactly, okay, your integer stuff, you've got to make sure that you don't make mistakes. Okay, so I'm just going to set this up. I make mistakes with integers all the time, and it bugs me to no end, okay, that I, okay, make silly little mistakes with my cross product here. Okay, so I've got 2 times negative 1, take away 0 times negative 2. Now I could stop right here. As soon as I have a 0 in here, that's not going to be the case. It looks like it's not going to be the case that I get any value here. It looks like I've got negative 2 as my component for my x, component for my cross product. Now I've got, okay, that's going to be 0 times 1, or just 0. Take away, now this is where it gets tricky, take away a negative and a negative. So take away a negative 1 and a negative 1. The product here, okay, that's going to be 0, right? The first part is 0. That's going to be a negative. A negative times a negative times a negative is a negative 1 here. Okay, now I've got my last component, my z component of my cross product. Negative 1 times negative 2, take away 2, 2 times 1 here. Okay, so I've got 2, take away 2 is 0, and it looks like I've got 0 here. Okay, so I could just classify this as rough work. Okay, you can do this, you can do that in the margin. Okay, and really, okay, you can, if as long as you get this, you can jump right from this line to this line. Okay, you don't really have to show any calculations or rough work. And I would encourage you, and maybe just be given the circumstances of our class now, I would encourage you to find a cross product calculator online. Okay, there's some really good websites to check your work. You put in the components of each of the 3 components of each of the vectors, and you just click generate the compute button, and you can get a cross product calculator here. Feel free to find them, check your answers, and do this. Okay, let's get on to Okay, the next one here. Okay, cross product. Looks like it's a long couple of properties here. Cross product between two vectors A and B is a vector quantity denoted by A cross B, having the following properties. A cross B is perpendicular to both A and B. The vectors A, B, and A cross B form a right-hand system. Remember, we did that with our thumb and index finger and second finger. Okay, and one other little property here that we are going to use and think in the next example is that the magnitude of A cross B is equal to the magnitude of A times the magnitude of B times the sine of theta. So let's see if we've got an example here where we can do this. Okay, so the magnitudes of two vectors A and B are 2 and 3 respectively. The angle between them is 60 degrees. Find the magnitude of the cross product of these two vectors. All right, let's see if we can rattle this off. I think this is just a straight application of my formula here, so I don't think it's really that big a deal of a calculation here. So I want to find this. It says magnitude of the cross product. Okay, now according to what I was just given, so the magnitude of A I've got to be 2, magnitude of B I'm given as 3, and I've got to do the sine of 60 degrees. So the sine of 60 degrees is a nice basic trig ratio here, and it looks like I got this to be, my 2's can cancel, so I've got 3 root 3. Okay, I don't need this little garbage piece here. Okay, I think that's it for an answer, 3 root 3. So that is the magnitude. I just found the magnitude of the cross product here using that formula here. I don't think we use this very much, okay, but it's something you might want to reference here in the future. Okay, a few more properties. Okay, following properties apply for cross product. Okay, these are quite intense, and there's proofs in the chapter in the textbook. I don't think I'm going to assign any of these for homework, but basically A cross B, is equal to negative B cross A. Okay, the distributive property for cross product. If I've got it equal to 0, then A. If I've got the cross product equaling 0, okay, then A equals 0 or B equals 0, or the two lines vectors are parallel, and A cross A is 0, right? Use the cross product properties to prove the following relationship here. Okay, so I've got A minus B cross A plus B is equal to 2A cross B. All right, so let's do the left-hand side. Okay, you know what I think I'm going to do? I think I'm going to go to, I'm going to pause this and go to my, so my left-hand side, I'm going to start with is A minus B cross A plus B. Okay, so this is the distributive property. So I can go A cross B. That's a plus, I'm sorry. Okay, and then I can go minus B cross A plus B. And then I can distribute this in. Now we've done kind of proofs like this, right? Plus A cross B, and that'll be minus B cross A, and then minus B cross B. Okay, A cross A is just, oh no, sorry, that's new. That was for dot product. So A cross B we just saw in our properties, is 0. Okay, now I've got A cross B. Okay, this property here, minus A times or cross A, minus B cross A. Okay, is A cross B. And then I've got another 0 vector when I cross two vectors that are the same. Okay, so it looks like I've got 2 A cross B. That's the right-hand side. That's what I wanted to prove here. So the properties we used are this, and this one here. And that was 2 properties from our first chart here. All right, let's get onto this and finish this up. Okay, I think I've got homework questions. So that's it. That's it for Our work, our homework questions are posted, just did that a few minutes ago, are posted in the homework help solutions. So good luck with cross product, and please make sure you practice enough of these. The first question in homework, question 4, I only assigned a couple, but if you're not sure about cross product, you could do all of these. Okay, thanks and good.